All right, I'm going to be going over the proportional reasoning formative. I haven't seen this, and I'm just going to walk through it and solve it blind, and hopefully you can get a sense of how you can approach these kind of problems. So let's go ahead and start. I have 12 minutes, so I kind of have to speak fast. All right, so car is traveling with the speed v when the driver slams on the brakes and stopping the car in a distance d. Suppose it was initially traveling with the speed 2v. How far does the car travel? How far does the car travel and come to a stop? So let's go ahead. I can probably split screen this, honestly. Let's go to my Notability really quickly. Notability. I should have pulled this up before, but I just jumped straight into it. Oh, that's my name. And okay, so let's split screen what we have going on here. Hopefully that didn't take up too much time. Oh my god, what now? Okay, let's just, oh my god. There we go. All right, so we got to choose a physics equation. So I know there's no time involved, so the physics equation I'm using is v squared equals v initial squared plus 2a d, right, or change in x. Because I don't know the time, but I do know the acceleration is going to be constant in both cases, and I know the, like when you're doing proportional reasoning, you have to find which two variables are going to be changing, which is obviously the skidding distance and the velocity, and then what other variables, everything else needs to stay constant. So I'm going to say, hey, this is going to be 0 at the end of this, and this is going to be constant. So I get negative v initial squared is going to equal 2a change in x. The negative sign is consistent because the acceleration is actually going to be negative anyways, because it's in the opposite direction, even though I guess when you square this, you don't see the direction. But it will end up being negative if you consider this to be positive. So the negative can actually go away. So I'm doing 2v initial squared going to equal 2a change in x, and you're going to see I get 4v initial squared, right? When I do 2v initial squared, whole thing squared, I get 4v initial squared. So in order for both sides to be balanced, my change in x would have to have gone 4 times as large. And you can do this problem, like, there's a lot of ways to do proportional reasoning, right? A common way is to be like, oh, question mark squared is going to equal, this is 1 times as much, the 2 is 1 times as much, the a doesn't change, so it's the factor change of 1, and then we're trying to find, or I guess, I'm changing the velocity by 2, but I'm squaring that, and I'm trying to see what factor change. I get 4 is equal to question mark, so it's 4 times as much. I have 5 problems, right? Oh, 6. All right, we gotta do this a little bit quick. Car's driving with speed v, and then the driver slams on the brake, and you can read the problem. It's really the same kind of scenario, but now what happens if the skidding distance is doubled, right? How much faster, by what factor would the speed change? I see I'm increasing the right-hand side by 2. I got to increase the left-hand side by 2. So I would get root 2 v initial squared, right? When I factor, I guess not factor, but when I put that inside of the square, right? When I square it again, I get back to here. So it would be root 2 times as much. Yeah, that looks about right. 2 identical stones are dropped from rest and feel no air resistance as they fall. Stone A is dropped from a height h, and stone B is dropped from a height 2h. And then we want to find how much time it takes for stone B to drop. If stone A takes like some amount of time t. So what physics equation am I going to use? Remember, I'm looking at which physics equation, right, are the two variables changing in this case, right, are going to be height and time. Those are the two variables I'm looking to see the change, right? I'm trying to see how does changing height affect time. Those are my two variables. V initial is going to be the same, and acceleration is going to be the same in both cases because it's free fall. So the equation I use is going to be h is going to equal 1/2 at squared, or I guess change in y. Suppose v naught times time, and this is going to equal 0 because v naught is going to be 0 in the y direction. So I get h is equal to 1/2 at squared, right? If I double the height, I just multiplied the left-hand side by 2, so I got to multiply the right-hand side by 2. And the acceleration and obviously the 1/2 are going to be constant. So the 2, right, is going to be essentially, it's going to be 2 times t squared, which we know is going to be 1/2 a, and then root 2t whole thing squared. So hopefully you can start kind of seeing that, you know, the square relationships and stuff. Object is dropped from rest, falls the distance d, and hits the ground with a speed v. How fast is the object going as it hits the ground if it falls a distance 2d? So what variables are changing? I'm trying to see, hey, how does the final velocity change? How does the height, you know, the height distance, I guess, right? Those are the distance, yeah, displacement. Displacement and final velocity. Acceleration is the same. Time is going to be different, so my equation can't have time, right? It's going to be the classic v squared equals v initial squared plus 2a change in y. And I can put little y subscripts. This is going to be 0. Vy is going to equal squared is going to equal 2a change in y. The change in y, right, doubles if I'm going to be doubling the distance. So this, if the right-hand side got greater by a factor of 2, so does the left-hand side. And then I would see, okay, 2vy squared. This is the same as root 2vy squared. I'm undoing the square root, essentially. I think that's what's going on. I guess that's a good way to put it. And I can see my vy is going to be root 2 times as much. Yes, that makes sense. Okay. Object is thrown upward at the velocity v initial, and it reaches a maximum height of h. And then if it's thrown 6h instead of h, what's the initial velocity thrown? I got to choose a variable or equation that only has height and initial velocity changing. In this case, in both scenarios, the acceleration is just 9.8, and the final velocity is going to be 0. So my equation can't have time because that's another variable changing. So I'm going to say, hey, v squared is going to equal v initial squared. I'm going to use this equation a bunch, times 2ah, or change in y, I should say. This is going to be 0 in the same way we subtract it over, but the acceleration's in the opposite direction of the displacement, so the negative you don't have to worry about. You essentially get v initial squared equals 2ah. If I make the right-hand side multiplied by 6 because of the height, I multiply the left-hand side as well, and I can see, oh, I'm going to have root 6 v initial squared. So I get this. Okay, cool. All right, now last problem. Object is dropped from rest, and it takes a time t. The same object were dropped from the same height on the moon. The acceleration is 1/6 as much. How much time would it take to reach the surface? So the changing variables are the acceleration, gravitational field strength, or acceleration due to gravity, and the time. Those are the two things that, or obviously, I hope by me saying that you don't think those are the only two changing variables. The other changing variable will be the final velocity of the block, right? But it's not asking about that. So I'm looking at time and A and T. Height is staying the same, so I can just use h equals 1/2 at squared plus v naught times time. That becomes 0. So h is going to be, oh, h is constant. So this is kind of crazy, right? H is constant. If I change the acceleration by 1/6 as much, well, in this side, right, has no change. So I have to make the t squared, I have to multiply t squared by 6 so that the 1/6 cancels out the 6, right? In other words, more intuitively, if the acceleration goes down, the time it takes is going to go up in order for the height to kind of stay the same. So if this is, 1/6, I would just do root 6t squared. And let's see how I did. Hopefully I did okay. Hopefully I got a 6 out of 6. Awesome. So yeah, thank you for watching.